Hello and welcome to another Chapter 9 practice problem. The problem we will be looking at today is similar to question 3 from Chapter 9, defining the null and alternate hypothesis and commenting on the decision to reject or to not reject the null hypothesis. The problem we're going to be looking at today is a company believes that their production process fills their bags of chips with exactly 60.2 ounces of chips. A random sample of bags is periodically selected and weighed to determine whether or not over or under filling is occurring. If the sample data led to a conclusion of over or under filling, the production line would be shut down and adjusted for proper filling. The problem is going to ask us to formulate the null hypothesis that will help in deciding whether to shut down and adjust a production line, to comment on the conclusion and the decision when the null hypothesis cannot be rejected, and to comment on the conclusion and the decision when the null hypothesis can be rejected. Before we can define the null and alternate hypotheses, we should first learn about what the null and alternate hypotheses are. The null hypothesis is the statement that contains the equal sign. This will always be true. For example, if we wanted to find out whether the average summer temperature in Arizona is 105 degrees Fahrenheit, our null hypothesis in this situation would be mu is equal to 105. The null hypothesis may or may not be what we are testing, but if the statement contains the equal sign, it becomes our null. The alternate hypothesis is the opposite of the null. If our statistical analysis tells us that we need to reject the null hypothesis, we assume that the alternative hypothesis is true for our data. The alternate hypothesis will always include the greater than or less than symbol or the not equal to sign. So for example, in our same situation from our null here, if we wanted to test if the average summer temperature in Arizona is 105 degrees Fahrenheit, if our null is mu is equal to 105, our alternate hypothesis is mu is not equal to 105. Part A is asking us to formulate the null hypothesis that will help in deciding whether to shut down an adjusted production line. The easiest way to test hypotheses is by using a 7-step process, and here I will be mentioning the first 3 steps. The full 7-step process will be gone over in detail in a later video. Step 1 is writing down the claim. In our case, mu is equal to 60.2. Step 2 is writing down the opposite of the claim. In our case, mu is not equal to 60.2. Step 3 is determining the null and alternate hypotheses. The null hypothesis, as we discussed, is the claim with the equal sign in it. So in this case, mu being equal to 60.2 is going to be our null hypothesis. The alternate hypothesis is the claim without the equal sign. In our case, mu is not equal to 60.2, so that is going to be our alternate hypothesis. Because the question is asking if the bags have exactly 60.2 ounces of chips, our null hypothesis must reflect that. Our claim is that our bags of chips are filled with 60.2 ounces of chips, so we are claiming that our bag contains an exact amount, which is why our claim has the equal sign instead of a greater than or equal to or less than or equal to sign. Because we're claiming an exact number, that is why our claim has the normal equal sign. So part B is asking us to comment on the conclusion and the decision when the null hypothesis cannot be rejected. Is there any evidence that our production line is not operating properly? If the null hypothesis cannot be rejected after our statistical analysis, then there is no statistical evidence that the production line is not operating properly. Therefore, we would not shut down the production. Not being able to reject the null hypothesis in this situation tells us that our bags of chips contain around 60.2 ounces of chips, where there is no statistically significant deviation from that average. For example, a bag could contain 60.3 ounces of chips, and we would be okay with that because the difference in weight could just come down to the size or shape of the chips inside. If the average weight was 65 ounces, for example, then we would have statistically significant evidence that our production line is either over or under filling the bags, and we would stop production. Part C is asking us to comment on the conclusion and the decision when the null hypothesis can be rejected. Can we conclude that over or underfilling exists? If we reject the null hypothesis, there is statistically significant evidence that our production line is either over or underfilling the bags, and we need to stop the production line to fix it. This tells us that the average weight of our bags of chips are either over or under 60.2 ounces, which is cause for us to shut down the production line and fix the error. This stems from the idea that if we claim the bags of chips contain 60.2 ounces, but they really contain 65 ounces of chips, like I mentioned in part B, then there is significant overfilling in our production line, so we would need to shut down the production line and fix the error. I hope this video was helpful in explaining this concept to you, and I will see you in the next video.